Let's solve a problem about a ball's motion in one dimension. The position of the ball is given by the equation x equals 2.0 minus 3.6 t plus 1.1 t squared, where x is in meters and t is in seconds. Let's visualize this motion with a graph. Here's our position versus time graph. And this is the path that the ball follows over time. Notice that it's a parabola, since the equation is quadratic. For part A, we need to find the position at 3 different times. At t equals 1 second, we plug in 1 for t and get negative 0.5 meters. Here's that point on our graph. At t equals 2 seconds, we get negative 0.8 meters. And here's that point. Finally, at t equals 3 seconds, we get 1.1 meters. And here's our third point. For part B, we need to find the average velocity between t equals 1 and t equals 3 seconds. Average velocity is the change in position divided by the change in time. That's 1.1 minus negative 0.5 meters, divided by 3 minus 1 seconds. This gives us 0.8 meters per second. For part C, we need to find the instantaneous velocity at t equals 2 and 3 seconds. The instantaneous velocity is the derivative of position with respect to time. Taking the derivative of our position equation, we get v equals negative 3.6 plus 2.2t. At t equals 2 seconds, we plug in 2 and get 0.8 meters per second. At t equals 3 seconds, we get 3.0 meters per second. Let's summarize what we found. The ball starts at x equals 2 meters, moves in the negative direction initially, reaches its minimum position around t equals 2 seconds, and then starts moving in the positive direction. The average velocity between t equals 1 and 3 seconds is 0.8 meters per second, and the instantaneous velocities show that the ball is speeding up as it moves in the positive direction.